Hi, today we're going to look at a couple of oxidation reactions of alcohols and also a dehydration of alcohols. So first of all, we should remember what oxidation is. Oxidation is loss, that's our oil, a loss of electrons or hydrogens, and gain of oxygen. And that could be also just C to O bonds would be gain of oxygen as well in organic chemistry. So in oxidation, we are going to be seeing carbon-to-oxygen bonds forming often. For alcohols, that's what we see. And they're going to form on atoms that are adjacent to each other. So just like in alkenes, we always were working across the double bond. We're going to see a similar pattern with the alcohols. For oxidation, I'm going to find that oxygen. That's where the chemistry is going to happen. And we are going to lose H's. We're going to lose an H that's attached to the oxygen, and we're going to lose an H that's attached to the carbon. Now, carbon and oxygen are each short a bond, so in the product we see that they need to share electrons with each other. That looks like this. I copy from the left. CH3 remains the same. Now it is carbon with just one hydrogen attached, and we see that a double bond forms to oxygen. This reaction took a primary alcohol, oxidized it, and turned it into this functional group here, which is at the beginning of the chain, and therefore an aldehyde. Similarly, for another alcohol, this one is a secondary alcohol. I'm going to remove a hydrogen from the oxygen, a hydrogen from the adjacent carbon. Those will be lost, and I end up with my product, which is going to be the same everywhere except for where that new bond has formed a carbonyl, and specifically this functional group, a carbonyl in the middle of a molecule, is called a ketone. So we see that primary alcohols oxidize to become aldehydes. We see secondary alcohols oxidize to become ketones. These are the oxidation half reactions, so we don't see where those hydrogens are going, but they would go to some other chemical that was being reduced at the same time. Lastly, we're going to look at another type of alcohol reaction, which is a dehydration. So here's our last reaction. We will be dehydrating an alcohol. And some clues to look for as I do that is, first I want to find the functional group. I see I have an alcohol. I'm not adding anything to it, but I do see acid here, and an alcohol plus an acid always leads to dehydration. Okay, in a dehydration reaction, we are going to be looking for losing a water molecule, and so I'm going to lose this OH from this carbon here, and then I'm going to lose an H from the neighboring carbon. And you can see together how that H and OH are going to give us the water. So here's what my product looks like then if I've lost a water. I copy CH3. This is now CH still to another CH. I have some water as a product. And then these two carbons here in the center have each lost a bond, and so they need to form a new bond, which is a double bond there. So when an alcohol undergoes dehydration, the product that I get is an alkene. To show that with a skeletal structure, let's see what that would look like. So here I had 3 carbons, and then I had an OH on this end. Always have that acid catalyst, that's the giveaway for dehydration. And then what's going to happen is the OH is gone, and I added a double bond, and then I will, because it's dehydration, always have water as a product. So there's our final reaction for alcohols.